coefficient. R is the correlation coefficient. R squared is the coefficient of determination. Okay, coefficient of determination. Anyone get that okay? All right, so far, what do we put in list 1? The independent variable. Which one do we put in list 2? How do you know which one's which? The one you're predicting is list 2. The variable that you feel tells you what the prediction is the independent variable that goes into list 1. Everyone okay on that? And everyone get those 2 in there. Okay.
Fun never ends.
Okay, what you're trying to predict is your dependent variable. That goes into list 2. The variable that you're using to predict it goes into list 1. If you were trying to predict a baseball player's salary, what might dictate that? The batting average. So the batting average, you put in list 1. The salary you're trying to predict goes into list 2. Okay? You get them flipped, you get the wrong relationship. R will be correct, but the relationship won't be correct. Okay? If something goes wrong, and you get them in list 2 and list 3, you just put L2, comma L3. That's all you have to do. Okay? So the calculator assumes the first one's independent, the second one's dependent. So the calculator defaults to list 1 and list 2. That's why I just teach it the way it was. All right? Coefficient of determinations R squared, A and B. So what is my equation? My equation is salary equals 8.67 times the GPA plus 4.07, right? That is my equation. That's my linear regression equation. So part A, determine the correlation coefficient. That is 0.94. Test to determine if there's a significant correlation at the 0.01 level of significance. We have to do a hypothesis test, right? We have to do a hypothesis test. Now the beautiful thing is, a hypothesis test is always the same for correlation coefficient. Always a two-tailed test, and it is rho equals 0, alternate hypothesis, rho does not equal 0. That's what we test. Rho is the Greek symbol for R. Okay? Just like mu is the Greek symbol for an average. Sigma is the Greek symbol for standard deviation S. Okay, so that's all we test. So if you're asked to do a hypothesis test for correlation coefficient, that's it. Never changes. And what we're testing is whether or not it's equal to 0 or not. That's all we're testing. Whether or not it's a 0 or not. Okay? So, alpha is 0.01, right? This is 0.005. This is 0.005, right? Always two-tailed. Never changes. Okay? So now the question is, what do we use for our critical value? Well, if I have at least 30, I go to where? Normal table, right? Standard normal, inverted norm. I don't have that many. How many do I have here?
7.
I have 7 values. That ain't 30. That's less than 30. So what do? I have to go to the T table. So now I'm in the T table. I'm in alpha, 0.01, two-tail. Degrees of freedom, I'm in the 7 minus 2 row or the 5 row. Right? I'm in the 5 row. I have to subtract 2 when we're doing hypothesis test or correlation coefficient. Yeah, yes. Whatever n is, you take 2 away. It's always a two-tail. It never changes. Take 2. Automatic. Never changes. It's always. So what do we get when we look in the t-table? Alpha 0.01, two-tail, row 5. 4.032. Everyone agree with that?
Yes.
Does anyone check it? Okay, so that means this is negative 4.032. This is positive 4.032. This is my do not reject region. This is my reject region. Okay? So now I have to compute the t-test statistic, right? And compare it, see which way to go. Test statistic's not so much fun. It equals r over the square root of 1 minus r squared divided by n minus 2, right? So in this case, that would be r is 0.94 divided by the square root of 1 minus 0.89 divided by 5. That's 0.94 divided by the square root of 0.11 over 5. 0.94 divided by the square root of 0.022. Is that right? 5 into 0.11, is that 0.022? Right? So what's the square root then of 0.022?
0.148.
148. And that goes into 0.94 how many times? 7 something. Maybe it's 6 something. 6.35. 6.35. So where's 6.35? Clear out here. So that means I reject the null hypothesis. So yes, I believe the correlation coefficient is not equal to 0. Or in other words, it is significant at the alpha 0.01 level. Okay, does that make sense to everyone? Not really. I don't think there is. Well, n minus 2.
Oh, okay, so it's 7 minus 2.
Yep. That's all there is to it. Is everyone okay with that?